I thank Realm for having us here. My name is Andrey. I lead the Kotlin team at JetBrains. And today I'm here to tell you a little bit about where we stand and a little bit more about what's next. I'll try to be concise because I don't have very much time. And so let's go. So first of all, what this talk isn't. It's not an introduction to Kotlin. So if you want to learn Kotlin, go online. There are many, many things to learn from. There's language reference, tutorials, talk videos. Check out our mini IDE, where Kotlin Cones is a set of problems that walks you through the language so you can learn easily. The same you can do in an IDE with educational plugin. Read the books, do anything to learn Kotlin. So I'm here to basically motivate you to go over there and learn. So my first thing is where we stand, and it's pretty much 1.0 because we released only in February. Since then, we were just doing incremental updates. So 1.02 is our current version. I can hear the dog. At the same time, we are working on 1.1. He actually wants to join us, I think. So we're working on 1.1, and this will be a feature-driven release, so I'm not giving you a date now. But the EAP, the Early Access Program, will start like this summer. So soon you will be able to touch the features I'm describing today. So a little bit more of where we stand now is this very nice slide. It's people who have been seen using Kotlin, maybe not admitting it publicly, but still. So JetBrains is, of course, a big user because we were probably first to start trying it in production. Now we have over 500,000 lines of code in production in different projects, from IntelliJ IDE of our main IDE to server-side products to everything. A few projects are written in Kotlin from scratch. Others are catching up, and we're, by the way, grateful to everyone trying Kotlin in production at such an early stage of the release time. So join in, you'll be in a good company. And being in a good company, you won't be alone. We have a lively community. Slack forums, Stack Overflow are full of people who are happy to tell you what you're doing wrong and how to fix whatever issues you have. By the way, joining the community, you can contribute. So you can come over to our GitHub project. It's all open source. You can join this over 100 contributors we already have. And if you're stuck, really stuck on a bug or something, we as a team work as hard as we can to be responsive enough. So we roll out bug fix updates as fast as we can. And if you have a critical issue, we'll roll it out as an EAP build that you can personally use to overcome the problem. Another community thing, it's a pretty new one, is Keep, Kotlin Evolution and Enhancement process, where we basically try to accumulate all the design process we're having. We're trying to be as open as possible, just starting that, but if you go to this GitHub repo, you have all the proposals that are considered for Kotlin 1.1 at the moment. You can provide your ideas, feedback, do corrections, discuss things with us, so on and so forth. And we're very grateful because your use cases is what drives our design, actually. So Keep is basically the venue for our plans, and that's where I'm coming. So as for now, we have 1.0, actually 1.02, as the main release, and our development is in 2 lines. So we have those incremental updates, 1.02, 1.03, so on and so forth, which are source compatible, which means that language doesn't change modular bugs. We fix bugs in the compiler. This sometimes slightly changes the language, but that's always for the better, believe me. And so there you find bug fixes, performance updates, and tooling features. Those features can be big. I'll show a list of a few of them. So this is where IDs are improved, build systems, everything else. And 1.1 is another parallel line where we actually do language features, and their source compatibility is backward compatibility. So 1.0 may not be able to compile 1.1, obviously, because there are new features 1.0 doesn't know about. But backwards, it's always compatible. So if you have your old code, it will work with 1.1. And this slide doesn't mention anything about binary compatibility because that goes without saying. We just keep it always there. Okay, now to actual plans. So in the lightweight branch of our development, 1.0 point something, we have many good things going on. Recently we released 1.02, which has incremental compilation for Gradle, which actually speeds things up quite a bit. So now, thank you. Now, when you change something in your Kotlin code and recompile it with Gradle with the incremental flag enabled, it's now an experimental flag, so you don't have it on by default. So if you do that, you only have those files recompiled that actually really need recompilation. So it's not like the whole project is rebuilt, but only those files, individual files that you touched or that were affected by your changes. So that's one thing, and we'll be working on this feature more and more, improving it, and after some time it will be not experimental anymore, hopefully. So that's one big infrastructural change. Then we have Spring support in the IDE, so now you have some of the features that the big IntelliJ IDE has for Java, but in Kotlin. So you can do lots of stuff that Spring integration provides and simply uses your life there. Next thing is that we're trying to reduce our standard library size, and that's not because our standard library is big, because it's probably the smallest among the alternative JVM languages, but we're trying to make it smaller. And last time we shaved off some 1,500 methods off the library binary and without changing the API. So it's a compatible change, but there are fewer functions now, and if you're an Android developer, it matters to you actually. And two more news for Android. It's lint checks. People were asking for those. So now the IDE warns you if you do something wrong in Android-specific terms, not language terms, but Android-specific things, and will have more and more lint checks added over time. And then Jack and Jill, the new Android toolchain, we're integrating with it. We're actually fixing bugs in it to be able to Jill compile the Kotlin standard library, because without the bug fixes it wouldn't. Okay, so this is the easy line. And then for 1.1, we're planning many things. And so the rest of this talk is actually dedicated to that line. So first thing, we're working on new targets. So our current target is Java 6. So whatever you compile in Kotlin can run on anything that runs Java 6, including, of course, Java 8 and 9. But it doesn't use the features of 8 and 9. So first thing we're working on is generating default methods for Java 8, where you can, basically in Kotlin you can always implement methods in interfaces, but then if you want to extend such an interface in Java, Java 6 wouldn't know that those methods are implemented. Java 8 would, so that's what we are supporting in 1.1. Next thing is we have some issues with Stream API on collections in Java 8. So these are now aided with a special library. We have a support library for Java 8 streams, but that will be removed in Kotlin 1.1, and we'll just support it natively in the compiler. So that's the first target. Then there is JavaScript. Actually, the JavaScript backend for Kotlin has been around for quite a while, but we deprioritized it to ship 1.0 for Java as soon as we could. So now we're working on it again, and all the language features are covered. We're working on runtime module support, so AMD, UMD, Common JS, whatever, and common tool chains. Unfortunately, JavaScript doesn't have a common tool chain. It has common tool chains, many of them, and we will try to support as many of them as we can. Then another rather popular question, can I run Kotlin in a native environment without a virtual machine? The current answer is no, at least not easily. And this is something we're planning to work on. So no code is written in this section yet, and it's probably not going to be available in 1.1, but we are looking into this, and we'll probably have some news sometime later. So these are like big directions, And now closer to the language. So one thing that's really needed from any modern language is it to be a scripting language. So this is actually more or less supported at the moment, although it hasn't been officially promoted that much. You can write a script in Kotlin. The file extension would be KTS. And for now, you can basically import anything and just write the expressions and statements on the top level of the file. It will be compiled to a Java class and just run as normal. So one thing that's missing for now is you cannot define dependencies inside the script. Which means that you have to either configure your class path somehow, or just be stuck with the JDK and the Kotlin standard library. This is something we are working on now, and it will probably help many other usages of Kotlin. So this is more an infrastructural change, and now to the actual language features. Language feature 1 is type aliases. So, you know, when you want to pass a function of, say, a foo and a bar to buzz, here and there and everywhere, you end up repeating this function signature over and over again, very many times. And that's why people want some abbreviation mechanism to somehow give a name to this complex type. So here my complex type is T2 boolean, it's a function, and I want a name for it, just a speaking name for here. I say type alias predicate of T is T2 boolean. So this is not a new type, this is just an abbreviation, an alias. Like int32 here is just an int. These are interchangeable, but they will help you abbreviate your long types and make your APIs more speaking. So the new type is something many people want, we know that. It's not something a type alias is, and it will be covered later, probably not in 1.1, with value types or something related to those. You've probably heard about Project Valhalla, those of you interested in Java at least. So along those lines, it's a lot easier coverable. Okay. Any questions here? You can just put up your hands if something is really unclear. Okay, I'll just move on. Next thing is bound method references. You probably know that Kotlin has reflection, its own reflection on top of whatever platform reflection there is. And there is language support for reflection. So those two colons, I say here like type double colon foo, is something that's supported now. So you can take a type and take a reference to its member, like a function or a property. Or you can take a type and make it a class literal by saying type double colon class. So this is something you can do now, but in 1.1 you'll be able to do that with an object. So you can take a foo, foo in quotation marks is a string obviously, and you can take an equals of that string, which is a function of one argument, and just put it to a variable as a predicate. So it will be comparing any string you pass to it to foo. So this is kind of a partial application, but a very limited one. Very convenient according to our use case surveys and stuff like this. So it more or less works like Lambda over there. The same thing you'll be able to do with a class. So you can take a class of exit foo by just saying double colon class. A couple of small things. Enhancements for properties. If you don't know what delegated properties are, who doesn't know what delegated properties are? Everybody knows. That's impossible. No. Just, okay, who knows what delegated properties are? Okay, that works better. Positive questions are better. All right, so if you don't know, please go ahead, Google it, because they are cool. Actually, this is something that allows very good code reuse in Kotlin. And the good news is that 1.1 will allow that as a local variable. So now you can use delegated properties on the top level or in a class. Now you'll be able to do it in a function. This enables DSLs and will help us with many use cases there. Another thing is inline properties. This is more a technical thing. For some libraries, for binary compatibility, it's better to have properties inlineable. Next thing, if you haven't heard of data classes, first of all, learn about them, and then I'll tell you a little bit. So the Kotlin has this very simple but very useful feature where you can define a class with two members there. So it's a class user which has a name and an age. These are basically fields. You can mark data, and the compiler will generate all this for you. So it will give you equals and hash code based on those values, toString rendering those, a copy method to just change the name of an object in a shallow copy of it, and a component functions for destructuring. Like you can say, I have a user. A user is basically a pair of name and age. So I can say, I declare a local variable name and age at the same time and assign the user to the two of them. So I have two values at the same time assigned to those names. So data classes are very good, but we didn't support any inheritance for those. 1.1 will fix that. So you'll be able to, say, have a sealed class and extend a data class from it. Basically, this covers everything people really need about algebraic data types in Kotlin. So it's not Haskell yet. It will never be. But it's as close to Haskell as actual use cases we see require. One more bit on the structuring. So you think of a map, it may be seen as a sequence of pairs, right? A map from, say, int to string is just a sequence of pairs, map entries of keys and values. So obviously in the library, map has a for each method that simply iterates through the pairs, and you can do whatever with them. But in Kotlin 1.0, you have only one variable for the whole pair. So you can say for each has an entry here, and you can say entry.key printed, entry.value printed. And this new syntax in 1.1 will help you destructure right away. So if you say K and V, it's a pair, it means that the entry is structured into the two, and then you can print the two like this. Okay, have I lost all of my audience by the no, okay. Okay, now I have a black screen for you. You're not supposed to read the code. All you care about is this staircase of brackets over here. So I don't know if you recognize this for its name, but this is the picture I Googled by the query callback hell. You know what that is, right? So basically, this picture being a typical piece of JavaScript, but not only JavaScript, other languages suffer from this as well. This basically illustrates the world of asynchronous computation as it is more or less today in many languages. So the thing is, we want to be asynchronous as much as we can because we like to offload things on different threads or other different ways of execution. So basically, the way we want to speak to many things, like the way I want to read from a file, is, okay, here's my file, I want to read from it, and when the read is done, here's my callback, call it when it's finished. And that's great, right? I can call something, I'm not blocking, I can continue working, and the read will do its work. Wonderful. But then if after that read, I want to write, and then another read, and so on and so forth, each next asynchronous call has to be nested inside that callback. So it's a callback, in a callback, in a callback, in a callback, and at the end I have this staircase here. It's okay if it fits in 150, oh, okay. It's okay if it fits in 115 lines, but sometimes it doesn't. And this is why some languages have this idea of async await. So basically, they want to write the same kind of code, asynchronous code that doesn't block on many calls, but in a sequential way. So I just say load bytes and then bytes to image, meaning that load bytes thing should actually work asynchronously and execute bytes to image only when it's done. So there is this await keyword that means call load bytes, put the rest of the computation away somewhere, don't block the thread, give the thread up to somebody else who can use it, and when the load bytes is done, resurrect the whole computation and run the next line. This is what C# introduced in version 5, I think, or maybe around 5 at least. And many other languages adopted this idea because it's very fruitful. And this is something we want to cover, but we don't want to copy it from others because it's not general enough, in our opinion. So basically what they have there is an asynchronous computation, a sync block, and a suspension point. Await means that we can suspend here and then resurrect afterwards. Now, what we want to do is coroutines. It's a generalization. Basically, we want to cover async await yield on generator blocks that you know from other languages, but with maximum flexibility. So basically, we want to support virtually all existing asynchronous APIs, futures, callbacks, promises, whatnot. And this means that the language is not bound to a given task framework or anything like that. So what we do with this example here, we actually have these async and await, but these are library functions, not keywords. So basically, it's the same machinery with a little bit different API and lots of flexibility. The prototype for this is underway. It will probably be available in June, and we all will be able to play with, experiment with library making and library using, using this abstraction. So I invite you to come to Keep and review the proposals. For those, give us your feedback, your ideas, your use cases. I think I might not have time for questions, but we can take that offline. Okay, so here I am. You can recognize me by this Kotlin t-shirt. So come over during the intermission. I'll answer all the questions. And now I have one last thing. So Kotlin has been known for making nice APIs, and some people like making APIs so much that I have an honor to invite Hans Doctor here on stage because he has something to show you.